For our last Unit 8 video, we're going to discuss radical functions. So we've discussed rational functions before, where the function has a ratio or fractions in it with denominators that include polynomials. Here we have radical functions, which just means we've got radicals in the actual functions themselves. And square roots mostly. We're not really dealing with anything other than square roots, at least as far as these examples in worksheet 8b are concerned. But like rational functions, radical functions, we have to be very concerned about allowing the value under the radical, this value under the radical, whatever it has to be, must be greater than or equal to 0. Because if we have this expression under the radical evaluate to a negative number, then we're going to have a complex number, and we're not working with complex number at this point, right, at complex numbers. So our radical functions we need to keep in the positive space under the radical. And that's what we have to check for to make sure, again, we don't have any extraneous solutions like we saw in some of our rational functions. So let's take a look at some of these questions. First question's asking us out of worksheet 8b is to determine the domain of the function. Well, this function's domain, you can put in any value of x you want, except you can't put in values of x that are going to make the function, the value under the radical, less than or equal to 0. So we just take each piece of the function, okay? We take each radical and we set x minus 3, which is the value under the radical, we just said has to be greater than or equal to 0. Well, also x minus 4 has to be greater than or equal to 0. So that means x has to be greater than or equal to 3, and x has to be greater than or equal to 4. Well, if x has to be greater than or equal to 4, then it can't be 3. So this particular one is trumped, this particular solution, x greater than equal to 3, is trumped by x is greater than equal to 4. And so this becomes our domain. Our domain are all values of x where x is greater than or equal to 4. And if we have a domain like that, then every value that comes into the range will actually be a real number, okay? Not a complex number. And how do we check that? Well, let's take a look. What if we put in 5? Well, if we put in 5 minus 3, that's going to be a positive square root, and 5 minus 4 is going to be the square root of 1, which is just 1. But what if we put in this value of 3? If x equals 3, well, we would have we'd have the square root of 0 here. That's okay. But then over here, we'd have the square root of 3 minus 4, which is the square root of negative 1. We can't have that. That actually is a complex number. So our domain is just simply the values x greater than or equal to 4. And again, we got that just by setting each radical equal greater than or equal to 0. Okay, so let's try this again for the next one. I'll get rid of this. And we'll try it for these guys. So we're going to say 3x minus 7 has to be greater than or equal to 0. And we're going to say that 9 minus x has to be greater than or equal to 0. So this is going to be 3x is greater than or equal to 7. X is greater than or equal to 7/3. And then over here, we're going to have 9 is greater than or equal to x. Okay, well, that actually, so we have now x is going to be less than or equal to 9. I just reversed the order of this and reverse the sign. It's equivalent. And then over here, we're going to have x is greater than or equal to 7/3. Again, this is just a re-expression of this. And so then this is our final answer, where x is actually between 7/3 and 9, inclusive. Okay, so our solution, this is what? 2 1/3, 2 1/3, less than or equal to x, less than or equal to 9. So on the number line, our solution looks like this. We've got 9 out here, and we got, we'll say 2, 3, okay, 2 1/3, inclusive, all the way out through 9, inclusive. That is the value of our domain. Okay, this is our domain. This is the value, this is the set of x values that we are allowed to put into our function. If we put anything outside of those values into the function, we're going to get a negative value under the radical, which we cannot have. Okay? So now that we've looked at how to figure out the domains, now let's see how we solve some of these radical equations. So we've got this first radical equation, which is the square root of x plus 12 equals -7. When we're gonna solve radical equations, the idea is to square both sides to get rid of the radical. We're gonna square both sides. Pretty straightforward, right? Because this is nothing more than x plus 12 to the 1/2 power. If we take it to the second power, then we're going to have x plus 12 to the 1 power, which is just x plus 12. So that's a long way of saying when we square both sides, we're going to get back the value under the radical. So square the left side, we get x plus 12. Square the right side, we get -7 squared, which is 49. And then so we can easily solve this, is 49 minus 12, 37. We've got our answer. And does it check out and does it work if we put 37 in here for x? 37 plus 12 is 49, square root of 49. Oh, wait, that doesn't work. We cannot have a negative value coming from this equation. There's no way we can have the answer to a square root be a negative value. So this actual function is undefined. This function has no solution. No solution. Okay, it has no solution because we cannot come up with a value under the radical that will equal a negative number. And I should have noticed that from the get-go. So you can go to the trouble of squaring both sides, but it's going to give you what we call an extraneous solution, right? It's not going to work because we need the positive value on the return in order for this to be a function. A negative value on a radical expression is going to give us a graph that would fail the vertical line test. So again, there's no solution on this one because we cannot set anything under the radical that's going to come up with a value that's going to give us a -7. All right. Now let's check out this next one where we actually, I believe, will get a solution. Okay. Square root of x squared minus 5x plus 1 equals 5. Again, the spirit behind this is to square both sides. And we got x squared minus 5x plus 1 equals 25. Now we can set this equal to 0 by moving our 25 over. X squared minus 5x minus 24 is going to then equal 0. Now we need factors that multiply together to get -24 and add together to get -5. That's going to be an 8 and 3 combination, I think. So we're going to have x minus 8, x plus 3, both equaling 0. So if we set x minus 8 equal to 0, we get x equals 8. If we set x plus 3 equals 0, we get x equals -3. These two solutions, x equals 8 and x equals -3, we need to double check and plug them both in and make sure that they're going to work for us in the original radical, and they will. 8 squared, 64, minus 5 times 8, 40. 64 minus 40 plus 1 is definitely 25. So the 8 works. And the -3, let's try that. -3 squared, this is the value under the radical, under this radical here. -3 squared minus 5 times -3 plus 1. Is this going to equal 5? So this is going to be -3 squared is 9. This is going to be a positive 15 plus 1 equals 25. We are good. Both of these, x equals 8 and x equals -3, are the solutions to this particular equation, that radical equation. Now, let's take a look at this very last one here. For what value of c will the function have the domain of -2 is less than or equal to x is less than or equal to 2? Well, we can simply set the value of x to -2 and then 2 to find out what the function evaluates to, or to make it so that the function evaluates where the square root is 0. Again, the whole point of this domain restriction is it's where outside of this domain, anything bigger than 2 is going to make the expression under the radical negative. Anything smaller than -2 is going to make the expression under the radical negative. And so in order for us to solve this, we just simply set this guy equal to each end of this inequality. Okay? And so we say -2 equals, what we want to do is we want to see if it equals 0. So we're going to set 0 equal to this with using 2 and -2 as the value for x. Okay? So this is going to be, and then we're going to solve for c. c minus -2 squared. That's the first one. And then we're going to do c, 0 equals square root of c minus 2 squared. And then we're going to get the same answer on each of these. You're going to see square root of c, this is going to be -4. And this is going to be 0 equals square root of c minus 4. Same thing. If we square both sides, we get 0 equals c minus 4, c equals 4. And if we square both sides, we get the same thing, c equals 4 again. And so clearly the value of c will be 4 in order to have this domain. Let's check it out backwards and see if we did our work right. Well, if we say f of x equals the square root of 4 minus x squared, and we're checking to find the domain. Remember, what we did to find the domain is we set this greater than or equal to, we set this so that it's greater than or equal to 0, yes. So we say 4 minus x squared has to be greater than or equal to 0. All right, well, if that's the case, then 4 has to be greater than or equal to x squared. That means x has to be less than or equal to 2. Or, of course, you know that means it's going to have to be greater than or equal to -2 as well, because both -2 and +2 will multiply together to get 4. All right, so we do check out. This is how we do this guy. You might see something like this on your weekly quiz. That's why I brought it in for you. Hopefully that helps you, and hopefully this video was helpful.